Alright, today we're starting a unit on quadratics. So if I showed you this equation, what does this look like? Easy method. Okay, this looks like easy method. But this form is in the, it's called a quadratic. Quadratic. And it is a quadratic if it's in the form ax squared plus bx plus c. Now what a, b, and c stand for, these just stand for numbers. They're just numbers. They're different. Okay? So as long as it's in the form x squared plus x plus another number, it's a quadratic. So if you flip this over, this is what a quadratic function looks like. It's also called a parabola. Okay? This is a parabola. Now these are both quadratic functions. Don't make me call you out. These are both quadratics, but they look a little bit different, right? This one goes up and comes back down. This one goes down and comes back up. So it's the same thing, right, Steve? Okay, look up here. Same thing, it just has different vertex. So let's look at this. The first important part of this graph is this point right here. It's the highest or lowest point. It's called the vertex. Vertex. It's the highest or lowest point your graph can go. So if you're looking at this point, the highest point is our vertex. And down here, this is the very lowest point. So that's also our vertex. If our vertex is up high, it's the highest point. It's called our maximum. So this vertex is also called our maximum if it's the highest point. If it's the lowest point, it's called a minimum, the opposite of maximum. Minimum. So that's our first thing we're talking about, vertex. It's the lowest point here, and it's called a minimum. It's the highest point here, and it's called a maximum. The next important thing is called your axis of symmetry. Axis of symmetry. It's the dashed line that's going straight through our graph right here. If you were to cut this graph directly in half, the line that you draw is called your axis of symmetry. So the line you draw to cut it directly in half, split it evenly, is called your axis of symmetry. Okay? Lots of vocab today. This point right here that I'm drawing, I just drew this point. This is your origin. It is 0, 0. That's your origin. It's just where you start. So this right here is your x-intercept, and this right here is your y. Wherever your graph intercepts your y-axis is called your y-intercept. Just like when we graphed lines, wherever it crosses the y-axis is called your y-intercept. Now, these points that are already drawn, these two black dots, these are called our roots. Roots, or where we came from. Alright, so we have our vertex, our axis of symmetry, where it crosses the y-intercept, and then our origin and our two roots. So over here, let's go ahead and write all of our different things that we just wrote. Well, what are these two right here where it crosses the x-axis? Roots. Good. Roots. Another word for roots is zero. Some people call them zeros. I call them roots, though. Okay, we already called this our vertex, and it's also known as the minimum if it's the lowest point. We have our roots, and then wherever we cut it directly in half. Yes, ma'am.
Can you please send Jacoby Jones to Miss Hayes' office?
Yes, ma'am. Right here, this is your axis of symmetry. This is where it cuts it directly in half. Axis of symmetry. So now that we've labeled all these points, let's go down here and actually write their definitions. All right, our vertex is the highest or lowest point. Good. Highest or lowest point of a parabola, which is also known as your quadratic. So your vertex is the highest or lowest point of a parabola. When your vertex is at the highest point, it is called a maximum. When your vertex, highest point. When your vertex is at the lowest point, it's called a minimum. Our axis of symmetry is the line that cuts the parabola in half. Cuts the parabola in half. Only intersects at the vertex. So it only touches another point unless it's the vertex. So right here, here's our vertex, and the only thing that intercepts the vertex is your axis of symmetry. Okay, next we have our roots or zeros. It's wherever or where the parabola, so our graph, crosses the x-axis. Wherever the parabola crosses the x-axis. And our y-intercept is where it crosses the y-axis. Jordan, I know what you're doing behind that binder. Okay, so you got this purple sheet, and these are quadratic keywords. So let's just look at it to try to verify this definition. Everybody put your head up. Don't even think about it. Up. Don't even think about it. Okay, so here, this is our quadratic. So here's your parabola. This is your highest point. So it's your vertex, but it's also called a maximum. Thank you, Diego. Here is your origin. So right here, this is your 0, 0. This is your x-axis, and here is your y. So wherever it crosses these x-axis, these are called your roots. So you have a root right here and a root right here. And then this would be your y-intercept because it's where it crosses the y-axis. All right, so let's practice identifying these parts. Yeah. Alright guys, so let's do example number 1 together. And then we're going to finish the rest of it in our groups. Headphones. Alright, so here's example number 1. I want you to answer all of these questions right here. So first question, max or min? Max. Here's your vertex. It's at the highest point, which makes it a max. Y-intercept. Well, right here is where it crosses the y-intercept. So most of the time I put y-intercept is equal, and at what point does it hit? 3. You could also put your y-intercept is 0, 3. Okay, we know our vertex is our highest or lowest point, so I've already put a dot at my highest point. If I start from 0, 0, how do I get there? Negative 1 up 5. So your vertex is at point negative 1, 5. Okay, here is your axis of symmetry. It's where it cuts it directly in half. This line right here. Remember, when we're talking about lines, if it's a vertical line, it starts with what letter? X. So our line of symmetry is this vertical line. So it starts with an X, and it's at which point? Negative 1. So your axis of symmetry is X equals negative 1. Okay, and then your roots. So your roots are wherever it crosses the x-axis. So here's a root, and here's a root. But here's the thing. It's not right on a point. So we have to guesstimate. Okay, let's guesstimate. So right here is 0, 0. So let's see how far this root is over. Well, it's over 1 and what? Like 1.6? You're not going to be counted wrong if you're close. It does not have to be the same as your neighbor. Doesn't have to be the same as mine. But it has to be close. So one of your roots is x is approximately, those two squiggly lines mean approximately, 0.6. And we have to do the other side. So if we start from 0, 0 right here, x is approximately negative 1, 2.6. So you have to go over approximately 2.6. 1, 2, 6. Alright, what I want you to do right now with your neighbors is finish 2, 3, and 4. We are going to present these. You just don't know which ones you're going to present.